Hello viewers, I would like to discuss few topics on microprocessor and microcontroller. In this video, I would like to touch upon microcomputer. As we all know, microcomputer is a system with the interconnection of CPU, central processing unit, memory and input-output devices. The block diagram is shown here. So CPU is nothing but a microprocessor. Memory, it contains memory. Again, there are two types in memory, ROM and RAM. So IO is nothing but input-output devices. These three systems are connected using system bus. So this is the block diagram of a microcomputer. Now we will discuss each of these three systems in brief. First, we will discuss what is input-output devices. Input-output devices, these devices communicate with the outside world. So what do you mean by outside world? Outside world refers to human users, or it can be any computer systems or any external devices. So through the input device, the computer receives data. Computer sends data to the outside world through the output devices. We will see now the pictures of some input and output devices. So this is an input device. It is called ASCII keyboard. It is an input device. So this is these three pictures are examples for input devices, and they are nothing but 4x4 matrix keyboards. Another example for input device is mouse. This is a mouse. Next we will see the pictures of some output devices. LCD. This is LCD display. This is an example for output device. Another examples for output device is monitor, LCD monitor. Then comes, this is a 7-segment display, and then comes a printer. This is a printer. These four are examples of output devices. Next we will see memory devices. So what is a memory? Memory is a device which stores instructions and data in binary formats. What do you mean by binary? It stores information in the form of ones and zeros. Instructions and data can be called as information. This memory provides this information, that is an instruction or data, to the microprocessor whenever it is needed or required. Now we will see the types of memory. Read-only memory, ROM. It is used to store information. As I just now told you, information means it can be an instruction or data and or data. So these information that do not require any change, those informations are stored in read-only memory. This picture shows the read-only memory chip or IC. This is an EEPROM IC. Next type of memory, random access memory. We usually call it as RAM. It is also called as read-write memory. So this memory is used to store information. As I mentioned, information is nothing but programs and or data that can be read and can be altered. In read-only memory, there is no possibility of changing the data or information. Now this picture shows the RAM IC, random access IC. Next we will see microprocessor, that is CPU. CPU is central processing unit, and this central processing unit is a microprocessor. This central processing unit or a microprocessor controls the entire operation of the microcomputer or microcomputer. This central processing unit or a microprocessor fetches the instructions from the memory, that is gets the instruction from the memory, it decodes the instruction and executes the instruction. So these are the functions of central processing unit. Now we will see, this picture shows the 8-bit 8085 IC. This is an 8085 8-bit microprocessor IC manufactured by Intel. Next we will see, this picture is a 16-bit 8086 16-bit microprocessor chip or IC. This is also manufactured by the Intel company. Next we will see, system bus is a group of wires or lines that carry binary information. So the information could be address, data, or read-write control signals. Types of buses we will see now. Address bus is a group of wires or lines that carry address of memory location or input-output devices sent by the microprocessor, and this is unidirectional. Second type of bus is data bus. So data bus is a type of bus, that is, it is a group of wires that carries instructions or data, okay, to and from memory or to and from input output devices and microprocessor. So the data transfer takes place between a microprocessor and a memory, or the data transfer will take place between a microprocessor and input output devices. Next type of bus is control bus. It is a type of bus, or we know what is bus is a group of wires that carries control signals. Control signals are again nothing but ones and zeros, but they are sent by the microprocessor. We will see the types of control signals. Memory read control signals, memory write control signals. Memory read control signal is used to read a data from the memory. Memory write control signal is used to write a data to a memory. Similarly, IO read control signal is used to read a data from the input device. And finally, IO write control signal is used to write a data to the output device such as printer. We will move on to the next one. This picture shows 8086 microcomputer. 8086 microcomputer. Now whatever we discuss, input device, output device, then memory devices, and then we discuss about CPU. Now we will see in this system where are these devices located. First one, this is 8086 microprocessor chip. This one is a EEPROM IC, ROM IC, used only to store data or program, but we cannot do any alterations for this program or data that are stored in this EEPROM IC. Next system is RAM IC. We can change any data or program in this particular RAM locations, RAM IC. Next is LCD display. This is an output device. Next we will see ASCII keyboard, that is an input device. And one final important thing, the heart of the entire system, microcomputer system, is crystal oscillator. So a microcomputer, to summarize, a microcomputer consists of three subsystems: microprocessor, 80 microprocessor, which is the CPU, memory, RAM and ROM, input device, keyboard, and output device, LCD display. So that was a brief introduction about a microcomputer. We will now discuss some operations of CPU. CPU performs arithmetic and logic operations. We will first see arithmetic operations examples. First example is addition of two 16-bit numbers. We will discuss later what we mean by 16-bit numbers. I will take two numbers 0007H. H indicates hexadecimal. H indicates hexadecimal number. So I would like to add this with 2, 0002. So addition of 7 plus 2 is 0009. Addition of two numbers, data 1 0007, data 2 0002. 7 plus 2 is 9. We will execute the program. Go 1000. Program executed. We will verify the result. Or 7 plus 2 is 0009. We just saw the demonstration of adding two 16-bit numbers. We'll next move on to the second example, arithmetic operation, subtraction. Subtraction of two 16-bit numbers. The same two numbers I will consider, 0007 minus 0002. The result is 0005. We will see the video the demonstration of this operation now. Second program, subtraction. Data 1 0007, data 2 0002. 7 minus 2 is 0005. We will execute the program. Go 1100, execute. Program executed. Verify the result. R 0005. So that was a demonstration of subtraction of two numbers. Now we will move on to the logic operation examples. OR operation, ORing of two 16-bit numbers. I'll consider the same two numbers, 0007, OR operation with 0002. The result is 0007. In the next video, I will discuss the OR operation and AND operation in detail. Now we'll see the demonstration of this OR operation. Now logical operations, OR operation, data 1 0007, data 2 0002. 7 OR operation with 2 is 0007. Execute the program. Go 1200. Program executed. Verify result. So result must be 0007. So result is 0007 for OR operation. So we will move on to the last example of CPU operations, ANDing operation. I will consider again the same two numbers, ANDing of two 16-bit number, 0007 ANDed with 0002. So the AND operation of 0007 with the 0002 is 0002. Now we will see the demonstration of this AND operation. Now last AND operation, data 1 0007, data 2 0002. Execute the program. Go 1300. Execute. Program executed. Verify result. So 007 and operation 002 is 0002. Result must be 0002. So result is 0002. We saw the demonstration of arithmetic and logical operations. In the next video, I would like to discuss procedure to enter programs, procedure to execute a program, procedure to verify results, and simple assembly language programs. Thank you, viewers.